Hi, lovely geometry students. Today we are going to be talking about section 5.3 from your textbook, inequalities within a triangle. So we're going to be looking at relationships between angles and sides of a triangle and also how we can relate angles to one another within that triangle as well. So just recall from chapter 4, we talked about the exterior angle theorem. So if we use this picture here, the exterior angle theorem said that if you have an angle exterior to the triangle, that it was equal to the sum of the two remote interior angles. So we can expound on that a little bit, and we can take it a step further and say that that means that individually angle 1 has to be larger than angle A by itself, and that angle 1 has to be larger than angle B by itself. So this is called the exterior angle inequality. And so it's just saying that that exterior angle is bigger than either of the remote interior angles when we consider them individually, right? Because it has to equal the sum, so it's to be greater than 1 by itself. So we can use this to create inequality statements within a triangle and the relationships therein. So let's look at a couple of examples. So if we use this inequality theorem, we can create lists of angles who are larger than or smaller than some triangles. So I'm going to walk you through part A, and then I'll let you guys pause the video and try part B on your own. So if we use the exterior angle inequality theorem, we can list all the angles who are less than 14. So here's angle 14. If we look, we can see that angle 14 is exterior to this little triangle here. So that would mean that it is greater than angle 4 and angle 11 because it is exterior to those two remote interior angles. We can use that same exterior angle relationship to say that angle 2 is less than and angle 3 are both less than 14 if we consider this large triangle here. So we would recognize that angle 14 would equal the sum of 2 and 3 and 4 together. But since we already know that 4 is less than 14, we can just add 2 and 3 to our list. Well, looking at this picture, I think there's a couple more things we can say. Knowing that 9 and 11 are vertical angles, that would also make angle 9 less than 14. Because if 9 is equal to 11 and 11 is less than 14, then 9 should be as well. And then again, using angle 11, I can see that angle 11 is an exterior angle to the triangle containing angles 6, 7, and 12. So that would mean that 11 is the sum of 6 and 7. So if 11 is greater than 6 and 7, then 14 must also be greater than 6 and 7. So using the vertical angles theorem and then the exterior angle inequality theorem, we can create this list that says that angle 14 is greater than angles 4, 11, 2, 3, 9, 6, and 7. So I'm going to give you a second. Why don't you pause the video and see if you can't use the exterior angle inequality theorem to list all the angles whose measure is greater than angle 5. So working a little bit backwards there. Give the video a pause, see what you can come up with. Nice job. I hope it went well. So let's check your answer. So you should have said that angle 5 is greater than the following angles. You should have said it's greater than, or I'm sorry, less than angle 10, 16, 12, 15, and 17. So I hope that went well for you. And you can ask questions about that one if you need a little bit of follow-up. The other relationships that we're going to be talking about are a little easier, I think, than that one. The first, this angle side relationship simply says that the largest side is across from the largest angle in a triangle, and vice versa. The smallest side is across from the smallest angle. So here's a couple of examples. If you know that the side XY is 9 and the side YZ is 7, then we know that angle Z is going to be greater than angle X because it is across from the larger side because 9 is greater than 7. And then vice versa from that, J is 110 and then angle K is 45. So we know that side JL will be less than side KL because it's across from the larger or the smaller angle. So we can use that to create a list, right? We can list the angles in order from largest to smallest. So if we want to start with the largest, we're going to find the largest side. So side AC is the largest, which would mean that across from that is angle B. So it's going to be my largest angle. The second largest side is the 14.3 BC. So that would mean across from that is angle A, and it will be my middle angle. And then lastly, 11.1 is across from angle C, and so it will be my smallest angle. And then we can work backwards as well. We could start with angle measures. So if I want to list the sides in order from smallest to largest, then I would look for the smallest angle first. So the smallest angle is angle B, and so that would be across from side AC. Oops, I clicked the wrong one first. There we go. So AC should come first, and then AB is across from the 55 angle at C, so it'll come in second, and lastly it would be BC across from the 80-degree angle. Here's a little word problem practice for you. So Tanya is following directions for making a kite. She has two congruent triangles, a fabric that need to be sewn together along the longest side. And the directions say to begin sewing the pieces of fabric together at their smallest angles. At which two angles should she begin sewing? This is kind of a silly question, right? Because we can clearly see that the 2.5-foot side is the longest side, so just sew them together. But to make sure that our corresponding angles line up, we should be able to check and verify which angles are the smallest. So across from the smallest side, on both triangles, the 1.5 feet is the smallest side. So across from that in this triangle is angle D, and from this triangle BC across from that is angle A. So she should begin sewing at angles D and A.